Yeah, hello everybody to our statistics course. We had two exercises left, and the first one was that we want to look at calculating skewness and kurtosis, and yeah, just taking some real data. So we want to calculate the monthly yields of the development of the DAX, the main stock index of Germany, since 1987. This was a date when the DAX was introduced. Okay, then I ask you that you could maybe have a look at the website of Bundesbank in order to get the money. Has anybody found the data? So this was our task. Oops. Oh, I have to open the chat. So then let's do it together. So we start and we go to the web page of the Bundesbank. Oops, where it is here. A bit smaller. You can also see this. So then and in this case we want to go as statistics part. So statistics, and there we have money and capital markets, and then we need the stock emissions, and in this case to go to time series when it works, emissions, and here we have the indices, and then we take the time series of the DAX performance index. Maybe you know this from other courses that the number you see every day in the news for the DAX, that this is the number of the performance index when the dividends of the shares are directly converted into the DAX. And this is, yeah, in difference to the numbers you see, for example, for the Dow Jones index in New York, because this is the course index and therefore they are not directly comparable. Okay, so we will download the data. And the macro statistics exercise, and of course I already had downloaded this data. And then if we take this data, we can go, oops, this was 7, that we then obtain here. Oh, you don't see this. Okay. Up to move my Excel sheet. No. So this is the yield of the DAX since 1987. And at first we can have a look how the yields are distributed, and this I've done here. Oh, this has to be a number, sorry. And for yields in between minus 25% up to plus 25%, the yields look like this. Let's take this diagram also to our slides, because then you see that we have a slightly left skewed distribution, and this we want to calculate now. And how do we do this? Well, we take the yields let's go to a new sheet. And if we have these yields, then we need our formula for skewness. And this we had here. So skewness was just the third moment. So we have to take the difference between our yield xi minus the average yield up to the power of 3 divided by the standard deviation also by the power of to the power of 3. So what we need at first is the standard deviation. How do we obtain standard deviation? Well, at first, of course, we need the average yield. So what we calculate is the average yield and this is just can be done with our formula. We had sometimes up and then we have to go up. This takes some time. Here we are. And having the average yield, we just calculate the squared distance. So this minus the average yield, 0.8. This again we have to fix with our dollar signs, closing brackets up to the power of 2. And this we have to do for every number. And summing up, dividing by n minus 1. So we have to look up how many data points do we have. So 417. So now you see it also. So this is our n. So we have to sum up these column and dividing this by 416. And after that, we have to take the root in order to obtain the standard deviation. So again, we sum up this. Oops, not squared, and divide this by our n, 417 minus 1. This would be the variance, and standard deviation is then the square root of the variance. So 5.88 is our variance. What else do we need in order to calculate the skewness? We need the third moment, so the difference up to the exponent of 3. So in this case, we then need xi minus x bar to the power of 3. So this is then, there we can more or less take this number and just change the exponent from 2 to 3. And since we will also calculate in a minute the kurtosis, we also need the distance between xi and x bar to the power of 4. This we will do also here. So then let's take this one and let's copy this here and to the power of 4. So this has of course to be done with every number. And then what we need is also the sum of these two. Oops. Oh, this was divided by, this we don't need. So, or we need it divided by n. So in this case, we have to change this and divide by n. And it's not d, but e. We need. And here also e. And the same with the column f. So, and these two numbers we have to divide for the skewness by standard deviation to the power of 3 and for kurtosis by the standard deviation to the power of 4. So skewness is then this number divided by the standard deviation 5.88 to the power of 3 and kurtosis is this number divided by standard deviation to the power of 4. And now we want to interpret these two numbers we have got. Go to our exercise. So the DAX yields have a skewness of minus 0.5 and a kurtosis of 4.86. So when we want to interpret this, we have then a negative skewness, and it is not very surprisingly, because if we look at the diagram here, we already see that it is slightly left skewed, so we should have here also not a 0 but a minus sign, and this we obtained. So we have negative skew, so we have a left skewed distribution. And interpreting our kurtosis, there the critical point is kurtosis of 3, because a kurtosis of 3 means that we have a normal distribution, and in our case we have a kurtosis which is a bit larger than 3. So this means that we have more statistical mass in the tails compared to the normal distribution, and also this is not very surprising, because if we look at capital market data and the yields in the capital market, then something which is really extreme, like an economic crisis or something like this happens much more often than compared to the statistical mass in the normal distribution. So if we look at a stock market index, we will also expect that we obtain a distribution which has in the tails more statistical mass, because these extremes happens much more often than in a normal distribution. Okay, so let's write this down. This was exercise 7. Up. No. Sorry. Screen sharing. Stopped. Why? Let's do it again. So now you should see the screen again. Oops. this doesn't working. Oh, some technical problems today. Try it this way. So you still see me, and it's now working? No. Can't I? Use my pen, hopefully. No. What's going on here? Can I use my pen? So, okay. But this is crazy. What happens here? No. Why is my pen not working? So I just stopped the recording. Maybe I have to change the battery of my pen.